How's everyone feeling? So, main thing on the schedule is that Test 1 season is beginning today. Today is Monday, February 19th, and so today, Tuesday, and Wednesday, the test will be offered in this room at 1:30 in place of attending lab this week. You can choose any of those 3 days to attend as long as your schedule allows for it. And lecture, both today and Wednesday, the 21st, will be entirely focused on answering any questions from you guys related to studying and the test and making sure you guys feel ready before test time. You again are encouraged to bring a non-cell phone calculator and a formula sheet. I have a stack of updated formula sheets right here. I may add a page to it as the semester goes on, but it has everything you need for this test already on it. So those will be right there if you haven't run off a copy of your own yet.
Is that second stack right there review sheets?
No, this stack is just scratch paper. So again, lecture today, we're going to open the floor up to questions from you guys. Make sure that anything that you have encountered while studying notes or homework or the practice test makes sense to you. And once you've taken the test, be that any of the 3 highlighted days on the calendar, you can basically consider yourself off until Friday. Friday's back to normal, because on Friday I'm either going to teach you or hand your tests back depending on how quickly I grade. So, test season is the highlighted days, return back to class for normal on Friday. So, with all that said, what's on your minds? Yes?
Can you explain the number 2 on the practice, the testing practice?
Absolutely. Number 2.
Or just how to get.
Yes, so number 2 is a displacement question. You are given a series of vector displacements and asked to find the net displacement in both the x and y axis. So to help with this, I'm going to kind of draw out this hiker's path starting from the origin 0, 0. First they hike 28 meters north, followed by 10 meters east, 5 meters south, 50 meters west. This is not quite to scale. 15 meters north, and then another 6 meters east. And my question is, what is the net x displacement from start to finish? And then separately, what is the net y displacement from start to finish? What is the x distance from here to here? And then separately, the y distance from here to here. And so to do this one correctly, you have to separate each direction into either being x or y axis, because x and y do not add together directly. So of these 6 vectors, north, 28 meters north, 5 meters south, and 15 meters north, I have placed over here in the delta y side of things. And the 10 east, 50 west, and 6 east, I've placed over here in delta x. Again, just separating north and south as y, east and west as x. Then add each of the respective types together, but factoring in opposites. So I tend to consider east to be the positive, just because most mathematicians like the rightward facing direction to be the positive number. So I put positives on the eastward pointing 10 and 6, and then negative on the westward pointing 50, and those would add up to negative 54 meters, implying to the west, seen here on my very rough drawing. And then in the y-axis, I would consider north to be positive, therefore the south ones have to be negative, bless you. So positive 28 north minus 5 south plus positive 15 north gives 38 positive meters from start, so that again points north. I don't do a lot of 2D work in here, but it's still important to consider what axis you are working in. Yeah? Okay. Yes?
Can you explain the question 5?
Yes. So number 5, I feel like 5 is a little bit similar in part because 5 is about a bunch of forces adding together, and you have to factor in both direction and axis. Here we have a box and multiple forces are pushing on that box. We have a 60 Newton force east, 90 Newton force to the south, a 20 Newton force to the west, a 30 Newton force north, and another 40 Newton force west. So the first question is, what is the magnitude and direction of the net force acting on the box? A net force is, by definition, all the forces added together. So kind of similar to number 2, we want to add all the forces together, but we can only add x with x and y with y. X with x and y with y. So separated that into 2 parts again. First, just adding all the x vectors together. We've got 60 east, 20 west, 40 west. Remembering directional signs, the east and west would be opposite each other. The x-axis force actually adds up to 0. Basically, all of the x forces are canceling out. There's enough force east to mitigate these 2 forces to the west. So the x net force, 0. Separately from that, in the y-axis is 30 north and 90 south. Since they point opposite each other, they must have opposite signs. And that's going to add up to 60 newtons southward. So the overall net force is going to be 60 newtons south, since the x-axis is just a net force of 0. The x-axis completely cancels out. That just leaves us with 60 newtons south in the y for the net force. Does that sound all right?
Now for B, it says like negative 60 with the grams. Let's say like there was like basically like 10 newtons going to like east. How would we? So would there be like another one of those for like?
Yes.
To the east?
Yeah. Like if this wasn't 0, if there was a net force of 10 east, then I would do this twice, once for y and once for x. And that would imply that the box's acceleration would point very strongly south and also simultaneously slightly to the right. And so if it's accelerating in both directions at once, its net motion would look something like that. Accelerating both down and to the right at the same time. But yeah, if there was a non-zero net force in the x-axis, you would do part of it twice. And that's a question. Okay. Yes?
For like the terms, like I know like Newton's law there would be like 5 terms and big thing. Would that be similar for like other types of terms, or will we actually have to write those down?
There's only one question where you have to identify the laws out of a lineup. Most of the other questions don't necessarily ask for you to define something. let's say for example, number 4 asks whether or not something is in equilibrium. So you would still have to use your definition of equilibrium to answer, but the only thing you'd have to write is yes or no. I do that to try to speed the process up. So very rarely do I ask for like a full sentence.
Is that friction that's exerting the force on the west?
Correct,
Okay.
yeah. I just decided to make the engine force rightward pointing, meaning friction would have to point opposite. You could reverse that. How y'all feeling?
Can you go over the difference between momentum and inertia?
Yes. Let's see if I actually have the slides for that. That was chapter 6. Bless you.
Thanks.
While I'm loading this, the main difference between momentum and inertia is that inertia is basically never zero as long as mass is not zero. Mass measures inertia. So as long as you have mass, you will always have inertia, whether you are moving or not. Because all matter resists changes to its motion. All matter, as long as, again, there is matter present, as long as the mass isn't zero, then all matter resists changes to its motion, and so you will have inertia even sitting still. When you're sitting still, your inertia is what's keeping you still. Momentum, however, is a vector that depends on both mass and velocity. The formula for momentum is mass times velocity. And so even when you have mass and inertia, you don't necessarily have momentum unless you're moving. Because you could plug in a non-zero mass into this formula, but a zero velocity and have no momentum, even though you would still have inertia. You only have momentum when you're moving. And when you're moving, then you can use that formula to figure out momentum, and that momentum specifically wants you to keep moving in the same direction forever. Because momentum's a vector, whereas inertia is just a scalar. So, small difference, one is a vector, one is a scalar. Main difference, you cannot have momentum if you're stationary, but you will always have inertia even if stationary.
Why does friction exist?
Friction exists because whenever matter is touching other matter, every solid, it doesn't even have to be solid, but solid surfaces, they all have surface imperfections if you zoom in far enough. And those surface imperfections act kind of like the teeth to a gear and sink into each other. The smoother the surface, the less of that there is, but you still can't get rid of it completely as long as the thing is made out of matter. Because if you zoom in far enough on the atoms, you will get a weird atomic surface where there's gaps between all the atoms. So everything is bumpy if you zoom in far enough. And those bumps lock into each other like the teeth of a gear and prevent things from sliding across one another. Literally like trying to drag sandpaper across sandpaper.
What does it mean when it says what direction does it point?
Friction always opposes motion. So if something's trying to move to the right, friction will point to the left. Whatever direction the motion is in, or even the attempted motion, friction will point in the opposite of that. Anything on your minds? Feeling good, I hope? Yes.
Can you explain A, or number 1A
1A.
on the practice?
All right. A car in a drag race starts at rest and accelerates at a certain rate for 6 seconds. What is the final velocity of the car? There's a couple different ways you could answer that one. I feel like the most direct option is using the definition of acceleration. Acceleration is change in velocity over time. And I'll rewrite this on the board so it's easier to see. I'll even write out the variables like I would if I was working it normally. All right, car starts at rest. That means its initial velocity is 0. It's going to accelerate up to some unknown final speed. That acceleration is equal to 14.5 meters per second squared. And it is gunning it, pedal to the metal, accelerating for 6 seconds. So that is the combination of the things that we have and that we want. I always find it useful to write that list out so that you can then glance at your formula sheet and see what formulas match this pattern. And again, the one that I think fits best is motion formula number 2. This is the definition of acceleration. If you're accelerating, your velocity is changing over time. And delta V, I'll rewrite this as well. Delta anything is always a final minus initial. So instead of delta V, you could choose to write out final velocity minus initial velocity. Final's what we want, initial's at 0, t is 6 seconds. We have the acceleration vector, so we could use this to find VF. That would tell us to what velocity we have accelerated to after gunning it for 6 seconds. 14.5 equals VF. Our initial velocity was 0, and it's always final minus initial over 6. So minus 0 just kind of goes away. Multiply both sides by 6. We get VF equals 14.5 times 6 for a final velocity of 87.6. Thank you. Meters per second. I don't know why, but sometimes I just have this thing where the wrong number comes out of my mouth.
When you multiply 14.5 times 6, it gives you 87.
Yeah, I got 87. I was just gonna say.
Just 87?
Yeah.
Oh. Oh, that does make sense. The heck was I doing? Yeah, because 5 times 6 is 30, so that should end in a 0. My bad. Sometimes I make mistakes on my answer keys,
Okay.
and I want you to point those out when it happens. Thank you. Bless you. I probably typed something in wrong or read it wrong. Thank you for bringing that to my attention. So yeah, VF there is only supposed to be 87, not 87.6.
Yeah.
My apologies. Similarly, I know for a fact I made a different mistake on here that got pointed out to me today. So I'll just bring that up while I'm thinking about it. Number 8, the two answers are both supposed to be 30,000, but for some reason I wrote 300,000. They are both supposed to be 30,000 for number 8. My bad. Yes.
Can you explain that one?
Yeah, absolutely. Before I do that, any questions about the other part of 1 before I switch gears? Okay. In that case, 8. Here we have an object being lifted up a 100-meter tall ladder, although in retrospect, 100 meters is a 33-story building, so maybe not a ladder, but mass up a height. We want to figure out how much work this takes and also how much GPE the object gains at that position. Formula for work. Work equals force times displacement. We're making the object displace 100 meters up, and the force we exert up needs to be enough to lift the item. If you want to lift something on planet Earth, how do you know the required force to lift something? Sorry, a little louder.
Like by how much it weighs? Like if I see it's a big box, like it's bigger than me, I know I can't move it because it's bigger than I am.
Right. The weight of the object is basically the threshold to lift it. Because in order to lift something, you have to, at the very least, get it into equilibrium to even begin towing it upwards. So, 30-kilogram box, its weight is going to end up being negative 300 newtons downward. And so to even begin lifting it, you'll have to exert 300 newtons up at minimum. And that is a general assumption you can make for the entirety of this class. To lift anything, you must exert a force at minimum equal to its weight but pointing upwards. So, technically I'm not plugging in the weight of the item, I'm plugging in a different upward pointing force. So that's why there's a positive 300 going in there to get 30,000. Does the first part make sense?
Can you explain the W equals F, change in one?
Yes, this is the work formula, although on your formula sheet, it's probably written with a delta X instead. You can write X or Y just depending on what axis you're looking at. It can change pretty easily. So this is just the formula for work, and this will tell you how much energy it will take to move an item that weighs this much by this distance.
What does F stand for?
Force.
Force? And
Yeah, this little symbol here, those are just, that is the symbol for parallel. And what it means is that the force has to be parallel to the displacement. If you're moving something up, you have to push it up. Does that help for now?
Yes.
Okay.
For like our formula sheets, can we like if for me it's easy to remember like what certain things are if I have like a little, so like F2 I can put like a parallel. If I like a little arrow and like pointing to like that, am I able to do that on the formula sheet? I just can't give like a practice problem, right?
Yeah, like if you were using a standard copy, you can write on this, because I've got a lot of students who want to label things specific ways. That is totally fine. I've got the parallel symbol on there, but I couldn't quite hear what you were saying. But anything else you want to write to help further know what this means and when to use it is totally fine. You just can't include like a work sample question. So that's the first half of this particular question. This is the work required to lift 30 kilograms vertically upwards by 100 meters. Again, 30 kilograms will weigh 300 newtons. So that's the force we have to exert. Force times displacement gives us that much work done. Separately from that,
Why do you multiply 30 by times 10?
that is to calculate the weight of the object. Because its mass is separate from the force needed to move it. This is how much matter is in the box. This is how much the box weighs. And to find the weight of anything on planet Earth, weight equals mass times g. G is just a value for gravity on Earth that is equal to -10. That tells you the acceleration of gravity, which, by the way, you can write g equals -10 on your formula sheet if it isn't already there. I think I forgot that one. So yeah, the force we need is equal and opposite to the weight. So this is calculating the weight. This is the force we must apply to overcome that weight. That force times the vertical displacement is the work done in this task. The energy it would cost us to do this ourselves. Do note, though, that that energy is separate from the work done just to get yourself up the ladder. So that's just the box. Moving yourself up the ladder will cost even more. Now the second part of this question is asking, how much GPE does the box gain at that point? Or have afterwards, meaning how much does it have now that it's 100 meters above the ground? GPE formula is mgh, mass, times g on planet Earth, which is again 10, times the height of 100 meters. And again, dang it, it's off center. I made a slight mistake on my answer key. The answer's supposed to be 30,000, same as the work. Because the work done to lift something is equal to the GPE gain. If I use up 30,000 joules of my own energy to lift something, energy's not destroyed, now the box has it instead in the GPE form. Also note, I put these brackets here around G. That's, I'm not using that as parallel though, I'm using that as absolute value, because G is normally negative 10 meters per second squared, but this formula doesn't care about the negative sign because energy is not a vector. So you just get rid of that negative sign because the energy doesn't care about vector directions. Energy is not a vector. I've added that bracket onto the most recent copy of the formula sheet. If it's not already there on yours for the GPE formula, you can add one. Again, just to make sure that you don't accidentally find a negative GPE, which implies something very different. So there's supposed to be the same answer, and that is the point of the question. Have I addressed the concerns of the person or people who asked about this one? Anything else on your minds? It's okay if not, because sometimes you don't know what you don't know. My plan right now is, I'm going to probably pause the recording if no one has anything they want to ask about right this second. Doesn't necessarily mean fast. What am I trying to say? Again, the point of today is to answer your questions. If you feel like you don't have any, then you may do what you will with your time. I'm again going to pause the recording, and if you guys need a break or want to just study, work amongst yourselves, absolutely do that. And then if you have any questions, let me know as they come up. But if you feel like you don't need any more out of today's study session, you may be on your way. I will be either in here or my office until test time, in which case I will be here until possibly Friday. Yes?
Will you be there for the Tuesday's test or not?
I will not. Since Dr. Edwards covers the Tuesday lab, he proctors the Tuesday test. But he has all the same, like I'm the one that runs the class, and so I'm the one that makes all the rules for tests. And so the rules for the tests are, whoever is proctoring it is to answer students' questions, make sure they understand everything that's being asked of them. Does that answer your question? Again, Wednesday is more study session. Yes. It's okay. Here's what it is.
So there'll be 10.
12 of varying length.
And only, I know you said in defined case, it's more like you just have the net and
Yeah, like each question, some of them are just concept, some of them are kind of a mix of concept and math.
But like one's like truly like defined in terms of the laws of motion.
Well, the way that one works is I list 5 statements and you have to pick which ones are the laws of motion and then number them correctly. So, and again, I do this to try to speed up your test process so you don't have to write out paragraphs. You have to identify them correctly out of the lineup, and I have changed the way they're written, so it's not exactly the same words, even though it does say the same thing. So you still have to understand what it's saying and know that one's first, second, third, or none.
I have a quick question.
Okay.
Number 8, I was confused on like GPE. I got how you got the work to get 3,000 joules, but I'm still a little confused on what GPE is.
So the concept of GPE is the amount of gravitational potential energy the object is going to have at that height. And whenever something is at a height, it has energy stored up that is released when it falls. And so when you're getting the box up here, the work that you're doing, when you do the work, you are giving up your own energy and giving it to the box to elevate it. So if we do 30,000 joules of work lifting the box, it's gaining that energy in the form of GPE, and it's just storing it there like a battery until it falls. So you can think of GPE in 2 ways. You can think of it as either the energy that is released when it falls. You can also think of it as the energy that was needed to get it up there in the first place. And so, oh, sorry.
To calculate GPE, would multiply the mass times the gravitational pull times the household. I see.
Yeah, I'm just rewriting it bigger.
Gotcha.
Yeah, the formula for GPE, which is on the formula sheet, is the object's mass in kilograms times the g, the acceleration of gravity of your planet, times your height above the ground. Yeah.
With number 9, I'm confused on E.
E?
Yeah, it's like I'm looking up the whole alphabet in a physics problem.
There is alphabet soup there. So the point of E is to try to demonstrate what happens to the ball's kinetic energy as it rises. The parts going from A down to E are meant to identify.
Yeah.
We have KE, we have this much of it.
I get A, B, C, and D, just E.
Okay,
It's
okay.
like, what's going on?
So in E, I'm showing, this equation here is called conservation of energy.
Mhm.
And it
Is
just
that
meant,
E, is that two E's? Like a cursive E and then a capital E?
no, that's sigma
Oh.
EI equals sigma EF. Total initial energy equals total final energy.
Okay. Okay. Interesting. So that's, can you repeat that?
Yes. Sigma EI equals sigma EF,
Mm-hmm.
meant to read total initial energy equals total final energy.
What is HF, a final height?
HF?
HF?
Oh, yes, height final, sorry, yeah, height final.
Okay, so JPEF.
GPEF,
Yeah.
yeah. So this is meant to show conservation of energy, the first line. The second line is trying to show what form of energy exists at each stage.
Mm-hmm.
Initially, we've got this much KE, and because energy is conserved, it's all gonna turn into GPE at that highest point where the ball freezes for a second.
Mm-hmm.
And so at that height, at that unknown height, plugging in the GPE formula here and the amount of KE you've already found.
And that's 400, right?
Yes,
Okay.
that is the same 400, but sometimes my 4s look like
That's
9s.
okay, mine do too. So then 10, or a 2 times 10 would give us the height that the ball's being dropped, or
Well,
will rise.
yeah, technically it's 400 divided by 2 divided by 10, which is also 20.
Okay.
How does the energy change from kinetic energy to GPE?
That process naturally happens when you throw something upwards. When I throw this golf ball, what form of energy am I giving it?
Kinetic.
Correct. As it rises, what happens? As it rises, does it speed up or slow down as it goes from here to here?
Slows down.
Slowing down. And if it's slowing down, that means its KE is dropping.
Gotcha. Gravitational pull bringing it back down.
Right. And so as it rises, velocity drops, meaning KE drops. But its height is increasing, meaning that its GPE is increasing,
Gotcha.
going from here to here.
Gotcha. Okay.
So the KE transforming into GPE is a natural process whenever a projectile is elevating, slowing down, rising to its apex.
Gotcha.
I think my laptop died. Sorry, guys. The rest of this study session might have to be analog.
Are we allowed to write what things are measured in on here? Like, can I write joules next to energy just so I can
Yes,
hopefully?
because you definitely should include units on your answers. So that is a useful thing to know.
Thank you.
You can put like, you know, like MG for certain things.
Have a good day.
You too, thank you. Yeah, correct. That is displacement. Yeah, so velocity equals distance over time. How far does it move each second?
acceleration velocity over time.
Correct.
I was doing another problem, you were talking about 9E.
It's okay.
So what you did, I see, did you multiply the mass times the, gravity?
Correct. So that would end up being 400 equals 20 times HF.
What was that formula again? For, what would we?
Yeah, I can put that on the board. I admit, sometimes in my haste, I skip steps. So I will always rewrite things for clarity's sake. It's this formula.
Gotcha.
I'll show the
Okay.
transformation from
I see.
line to line. Now, I kind of skipped to this just being 400, the KE, because that was solved for earlier.
Yes, sir. Okay, gotcha. And you use it by 20 on both sides, and 20 times 20 is 20. So 20 is equal to the height.
Yeah, 400 divided by 20 is 20.
Okay.
I didn't intend for that many 20s to pop up, it just kind of happened.
Can you spell number one?
Number one?
Yeah, sorry.
That's all right. I might need to get you to remind me the distances listed because my computer's dead. But I'm draw them out to try to show how the axes work and don't work together. I believe the first one listed was 28 north.
That's number two.
Oh, I'm so sorry. Number one was the.
The drag race.
That's it. I'm so sorry. I think I remember some of those. Velocity initial 0, VF is unknown. Acceleration is 14.5 meters per second squared, and the time is 6 seconds. Is that all right?
Yeah.
Okay. The first thing asked for was final velocity. I like writing out all the variables so that I can look at the formula sheet, see which formulas have these things in them. And that's why I, when making my answer key, was drawn to the acceleration formula, because it has all the terms present in it. Do note again, anytime you see the delta triangle, that means final of that thing minus the initial of that thing. So I can rewrite that formula as A equals VF minus V initial over time. So again, this one has all three things that we know and the one thing that we want. Feel good so far?
Yeah.
Okay. So acceleration of 14.5. VF is what we want to know. Initial velocity 0. We were starting at rest and we're going to speed up to something after accelerating for 6 seconds.
Multiply 6 on both sides.
Yep. So 14.5 times 6 is going to be equal to VF. And I did make a mistake on my answer key. The answer here is just 87. I don't know where that 0.6 came from.
Yeah, I don't know. I feel like when I look at these problems, I just put A for acceleration instead of just putting like, VI, VF. Those things kind of confuse me a little bit.
My next question is, if we work on this, like we can do this review, how do you, cause you want those teachers to like give us a review, but like make the test like different, you know what I mean, or like?
Yes, it is different, so like, the questions won't have the same numbers, they might not describe the same scenario, but I wrote the test first so that I knew what types of questions
Gotcha,
would
okay,
be
that's all
there.
that's because some teachers, you know, they make her exam and like, they ask you those questions, but they don't ask those questions, like,
Yeah.
you know what I mean, so I was just making sure.
Well, and to try to be aware of that, because sometimes I see all the correlations and they make sense to me, but they don't necessarily make sense to someone who isn't me. So I've actually gotten in the habit of putting an extra bonus question at the end, or I straight up ask, what did you study that you don't feel was on here?
Gotcha.
And if you can summarize that, I usually give a few extra points for it.
When this says, what's the final of the card, how far is travel this card? 7, right?
Sorry, say it again?
It says, how far does the car travel during this time?
Yes, so that would be asking for the distance, the displacement, and the variable for that is delta x.
That's a good question, actually.
So I'm just gonna change my variable list over here. After the first part, we've solved for, whoops, that's supposed to be meters per second. We've solved for the final velocity. That is now something we know and can use if we need it. And now we are after delta x. We want to know how far we travel while speeding up, because you always are moving forwards while that happens. You hit the gas and you don't immediately jump up to 60. It takes both time, but it also takes distance.
And what's the formula for distance?
There's a few of them. The one that I would recommend that has most of these terms and delta x in it is formula number 3. I call it that because it's the third one on the top left there.
Oh, A of x is equal to initial velocity times time plus 1/2 times the acceleration times squared?
Correct.
Gotcha.
Because, again, this will tell you how far you travel after you accelerate for a certain amount of time. It also factors in how fast you were initially moving, but our initial velocity is 0, so this whole term's just gonna kind of go away.
Gotcha, okay. That makes sense.
And I forget what that turns out to be. I wrote 261 on the answer key, right? Now, that is not technically the only way you can get that answer. Because just because it's the way that I would do it doesn't mean it's the only way.
Yes.
One other formula that comes to mind that should give you the same answer would actually be the 4th one in that same column of motion formulas. Because this formula also has a delta x in it, and the other variables are things that we've already worked out.
That is acceleration, right?
Correct. So,
And V of O is, that's the square, what's the V of?
oh man, I meant to change that. VO and VI mean the same thing. I meant to try to make that VI, but it's
Initial velocity.
escaped me, yeah. VI is initial velocity. V0 is also initial velocity, because some scientists make it a 0 to demonstrate that this is at time of 0.
Gotcha, okay. Makes sense.
Furthermore, one of the teachers I learned from is South African, and in other English-speaking countries, they don't say 0, they say naught, N-A-U-G-H-T. So in my brain, there's 3 versions. There's VI, V0, and V naught. I'm trying to keep it consistent, but that one slipped past me.
Gotcha. Everything, like, if you put the numbers in front of me, the numbers make sense. I just have a hard time, like, deciphering what letters mean what, if
Yeah.
that makes sense. It's like, if you told me, like, math, like velocity and all this, in that formula, I would definitely know what I was doing and be able to plug in everything. It's just the AI and the delta and all that. Well, but I'm studying that tonight. I feel kinda okay with that's the only thing that's gonna trip me up. Like, I'll probably put the wrong formula in and don't know what formula to use because like other letters, but.
Yeah, that happens sometimes, and it's why I like writing them out, because if you have here, you know, the letters, you can at least find what formulas have the same letters in them.
Yes.
And it's also why I encourage students to always show their work, because I will give you points for everything that you do, even if you use the wrong formula. Using any formula is still worth points.
Gotcha. Also had the lab from last week.
Cool. Just give me 1 second. Forgot my camera was still running.